form for basically it's overall how do you find the equation of a line, which some of you have kind of picked up on a few things already, I've noticed. So if you're asked to find the equation of a line in gradient intercept form, so just be aware that gradient intercept form means in the form of y equals mx plus c. What is m again? Have a think. That's right, it's a gradient, like the rise over the run. What is c again? That's right, it's the y-intercept of the graph. So the equation of a line could be something like y equals 3x plus 5, for example. Basically, you need to replace the m with the value of the gradient and the c with the value of the y-intercept. And y and x should stay in the line equation. So in gradient intercept form, it's called gradient intercept form because it's got the gradient here and it's got the y-intercept here. So now let's try some applications. So find the equation of a line in gradient intercept form with gradient of 7 and y-intercept of -1. So this isn't actually complicated. All you have to do is you have to substitute in 7 for the m because that's the gradient, and the y-intercept is -1. So it'll be, have a think what it would be. Feel free to write it down and now check it. It will be y equals 7x minus 1. Some of you might have written 7x plus -1, which isn't incorrect. It's not incorrect, but this is just the more simplified version of it, because a plus negative overall is a negative. So 7x subtract 1 is how you would write that one. Next one, a gradient of -10 and a y-intercept of 1/4. Again, just substitute it in. M is -10 and the y-intercept is 1/4. So think what it would be. Feel free to write it down and try it yourself first. Y equals -10x plus 1/4 is what you would get. Next one along, gradient of 0 and a y-intercept of 1. So again, just sub in 0 for x and 1 for c. So you could first of all do that. So I'll scroll down a bit. So you could first of all do this straight up 1. Y equals 0x plus 1. But then again, try to think if anything's multiplied by 0, what happens? That's right, overall it becomes 0. So overall, instead of just writing y equals 0x plus 1, you can simplify that because this becomes 0, y equals 1. So what's interesting is, if it's got a gradient of 0 and a y-intercept of 1, because remember gradient is rise over run, so if it's got a gradient of 0, it means it's got no rise at all. So what kind of line has no rise? That's right, it would be a horizontal line. So a horizontal line, the equation of a horizontal line is just y equals the value of y that it cuts through, because it's got the gradient is 0, so this part would disappear. So that's why the equation of a line like this is just y equals 1, because it's got no rise. So therefore rise over run is 0. Same thing there, you don't need to write it twice. Another one, gradient of -1/2 and a y-intercept of 8, just a straightforward one again. Substitute it into your equation for a line, and what would you get? Now check your answer. Y equals -1/2x plus 8. That's correct. Interesting one, a vertical line that cuts through this coordinate. So try to think what that would look like on a graph. Let's draw it out. Let's draw our coordinate plane, our y-axis, our x-axis. Let's mark in the coordinate 1 and 4. So coordinate 1 and 4 could be somewhere like here. Doing a different colour if it helps. So coordinate 1 and 4 could be about there, cuts through x is 1, cuts through y is 4. And it's a vertical line that cuts through that. So then we'll just draw a vertical line through there. What's interesting is vertical lines have undefined gradients. As we said, horizontal lines have gradients of 0 because rise over run, the rise is 0. The run is infinite, but the rise is 0. So 0 divided by any number will just give you 0. Whereas vertical lines, they have an infinite rise, but their run is 0. So rise over run would be something over 0. Remember, anything divided by 0 is undefined, because in mathematics we can't divide by 0, it's not allowed. So vertical lines have what we call undefined gradients, because it's got no run, so the rise over run is an undefined value. So if it's a vertical line, the equation of a vertical line, you don't bother with y equals mx plus c, it's just what is the value of x that it cuts through. It just cuts through x equals 1. So interesting, that one. Again, a horizontal line that cuts through this coordinate 3 and 5. Good idea might be to graph that, and just so you get an idea of what it might look like. So here's your x-axis, make sure to label it x. Your y-axis, y, make sure to do that too with these ones. That one's already labelled x. So it cuts through a point, y equals 5. So x is 3, y is 5. Let's draw in the coordinate. So if that was x is 3, y is 5, it would be that here. And it's a horizontal line that cuts through that. So try to think, the equation of a horizontal line, y equals mx plus c, would have a gradient of 0 because it's got no rise. And it would have a y-intercept of 5. So you can just think of that as y equals 0x plus 5. The 0x just simplifies to 0, so it's y equals 5. So vertical lines have equations x equals a value. Horizontal lines have equations y equals a value. Let's move on to the lesson. Okay, gradient intercept form versus general form of the equation of a line. On the warm-up we were dealing with equations that were in what we call gradient intercept form. Every line can be rewritten in the form y equals something x plus c. So you might have realized what that is now. It's y equals mx plus c, which we call the gradient intercept form because it has a gradient. The gradient is the coefficient of x, and the y-intercept is a constant term. So y equals mx plus c. Gradient intercept form. So what does m equal again? That's right, m equals the gradient. And what does c equal? It's the y-intercept. So yeah, m is the gradient and c is the y-intercept. Equations of lines can be expressed in gradient intercept form, which is here, or the other form, which is what this lesson about, which is general form. General form, see y equals mx plus c here. General form has got the x term and the y term on the same side, and the constant term also on the same side. So basically, this is y equals mx plus c rearranged. So y equals mx plus c, but it's been rearranged. What's important though, these numbers have to be whole numbers. So if you end up with fractions here, you need to multiply each term by a certain amount so that they become whole numbers. So this is y equals mx plus c rearranged, because see, basically if you had the y here, if you subtracted over the mx and subtracted over the c, you would get this. And then you just need to multiply each term by something if they're not already whole numbers. But you'll see some examples of this later on. So where a and b don't actually represent anything in particular, for example, not necessarily the gradient, the y-intercept or anything necessarily, but they must be integers. So in the general form, these must be whole numbers, positive or negative whole numbers. That's what integers are. Remember, y equals mx plus c, the gradient intercept form, you can have fractions here, that's fine. Fractions, decimals, no problem. In the general form, it's required that these a, b, and c are whole numbers. So the general form must always be also set equal to 0 because you've subtracted basically all the terms onto this side. Okay, you need to know both forms of these in case the exam questions requires you to write down the equation of the line in either gradient intercept form or general form. So in exams they can actually ask you what is the equation of the line in the general form, or what is the equation of the line in the gradient intercept form. So you need to be prepared to be able to do both. So to find the equation of the line, you need two things. You need to be able to find it in gradient intercept form first, I would suggest. And then if they require the general form, I would say find this form first and then rearrange it into the general form is what I would suggest for now. So to find the equation of the line in gradient intercept form, you need two things. You need something that starts with g. Try to think what that would be. That's right, that would be the gradient, because you need y equals mx plus c. So you need the gradient. So quite often they might give you the gradient in the question, or they might have asked you to calculate the gradient in a previous question. So just be aware sometimes it's given to you. If it's not given to you, you would need to calculate the gradient yourself. For example, if they give you two coordinates, you can use the gradient formula to calculate the gradient. y2 minus y1 over x2 minus x1. You also need something on the line that starts with p, and you can use this something to substitute in for x and y to solve for c. It is a point. So you need You need the gradient and you need a point on the line. And that point on the line helps you to calculate the y-intercept. Unless of course, if it gives you the y-intercept, then that's fine. You can just sub in the y-intercept. So let's find in gradient intercept form the equation of the line through this coordinate. So we've got a point on the line and we know what the gradient is. So we're going to find it in gradient intercept form. So y equals mx plus c form. That's what we tend to start with. That's what I would suggest you start with anyway. So we know that the gradient is 5, so we know that m is 5. We also know a value of a coordinate, x and y. So we can substitute in 5 here. We can substitute in the x and y value from the coordinate, and we can solve for c to find the y-intercept. Easily done, but you just have to be nice and careful. Steps are, write down y equals mx plus c. I'll do the working out afterwards if you want to see a worked example first. First step, write down y equals mx plus c. You can do this yourself underneath if you prefer, and then just see if you've got the same as me. Then replace m with the gradient, 5. That could be on your next line of working. As you're given it in this question, you didn't need to calculate it yourself. Also in the next line, I would suggest substitute in x and y. So I would write y equals mx plus c, then I'd write y equals 5x plus c, then I would write 3 equals 5, brackets, negative 1 plus c, because I've subbed in the rest. Fourth line, I would write down the equation of the line with numbers instead of m and c. The variable x and y remain there. So you'll see in the end what I mean by 4. You'll see in my working. Write down the equation of the line, mx plus c, that's his first step. Now step 2. Replace m with the gradient, because you're given it in this question, you didn't have to calculate it. Step 3 is what we're doing now. We're solving for c, substitute in the values of the coordinate as well as the gradient, and then 5 times negative 1 is negative 5. Then you need to add 5 to both sides to get c. Last step, write down, this is what I mean by part 4, write down the equation of the line with the numbers instead of m and c. The variables x and y must remain there. So you don't replace x and y with numbers. You just did that here in order to work out what the c is. So your final answer should be the gradient intercept form of an equation of a line, which is y equals something x and then plus or minus something. Could possibly be 0 even. So that's the equation of the line. So it's got a gradient of 5 and it's got a y-intercept of 8. Now let's do another example. Find in general form this time, a bit more confusing, the equation of the line which goes through this point, 2 and x, so that's our x and our y value. Might want to just remind ourselves of what the purpose of the coordinate is. It's so that you can substitute in an x and a y value and a gradient of 4. So it's going to be our m. So I've written down some steps for you. Steps, do the same as the previous page. So find the equation in gradient intercept form first. Write down the equation, replace it with the gradient, same instructions as yesterday. Substitute in the coordinates of x and y, solve for c. Write down the equation in gradient intercept form first with m and c subbed in, x and y remain there. Then this part is the next part that you will use to convert it into general form. Then rearrange the equation so that x, y and the constant term are on the same side, and the equation is therefore set equal to 0. If any of your values of a, b or c are not integers, whole numbers, multiply each term by whatever it takes to turn them into integers, which might not make sense, but when we see it in practice it might make more sense. So first of all, we're going to find in gradient intercept form first. So y equals mx plus c, step 1. Step 2, substitute in your gradient. So as I've said here, find in gradient intercept form first, then convert to general form is what we're trying to do here. Don't know what that's doing there. So I've subbed in my gradient because we were told that in the question that it's a gradient of 4. Substitute in the coordinate x and y. 4 times negative 2, what's that? It's negative 8. Then add 8 to both sides. You will get c is 13. Now write the final equation in gradient intercept form. Just sub in the m and the c. M is 4. What is c? 13. So here's our gradient intercept form. That would get you a fair few marks just doing that. Now to convert this into general form, we need to either, with 2 ways we can do it. We can either leave these here and we can subtract y from both sides. Alternatively, we can leave y here and we can subtract 4x and 13 from both sides. It's the same answer either way. So I see what I've chosen to do is I've chosen to add y to both sides because it was less work. I want to do the step that takes least work for me. So what's important, so we've got y equals 4x plus 13, and I've subtracted y from both sides. So the good thing is general form, it's got to be set equal to 0. That's why I subtracted y from both sides. This is almost finished. The last step though, it needs to have your x term, then your y term, then your constant term. So that's what I've written here in red. Put in the correct order. So you've got to have your x0 equals x term, y term, and constant term. And the good thing is a is 4, b is -1, and c is 13. So they're already whole numbers. No need to have to do anything with these ones. They're already whole numbers. Life's good. Next example. Find in gradient intercept form the equation of a line that passes through two coordinates. So remember gradient intercept form, you're not given the gradient this time, but you've got to calculate it yourself using the gradient formula. So gradient formula, that's what I've said here. You're not given it, so the gradient this time, but you can calculate it using the gradient formula. And you'll have to use, remember, x1, y1. So let's label our coordinates, because gradient formula is involving y2 minus y1 over x2 minus x1. x1, y1, so the other coordinate is x2, y2. Try to remember what the gradient formula is. The gradient formula, remember, y2, it's rise over run, so y2 minus y1 over x2 minus x1. Substitute in the values, just substitute it in y2 minus y1 over x2 minus x1. What's the numerator is -5. What would be the denominator? That's right, it's a -1. -5 divided by -1 is +5. So we've got a gradient of +5. Lovely. So we can say so far we know our equation is y equals 5x plus c. So we were given two coordinates. So to sub in x and y, you can use either of these ones. You could use that coordinate, sub in x for y and solve for c, or you could use this other coordinate, and you will get the same answer either way. So if you're worried about your answer, you can check it by trying both. So what I've written here is just what I said. We were actually told the y-intercept. Oh, actually, you could have done that, but on top of that, we're actually told what the y-intercept was, because notice one of the coordinates was 0, -1. So that's the y-intercept. Alternatively, you could have done what we said. Substitute in x is 0, substitute in y is -1, and you would solve for c, you would get -1. So that's in gradient intercept form already, which is great. Next one, find in general form the equation of a line that passes through this point here with a gradient of 3/4. So what we've got to do is just start finding it in gradient intercept form first. We know the gradient, so sub in the gradient first. We know a point on the line, so sub in x is 5, y is -2. And then what's 3/4 times 5? If this is without calculator, you could think of that as what's 3/4 times 5 over 1. Multiply the numerators, multiply the denominators. That's what we've got. And now we've got to do -2. We've got to subtract 15 over 4 from both sides. So -2 subtract 15 over 4 equals c. We're solving for c. And when you think of it, I've kind of skipped a step here, but why does that minus that equal this? So try to think when you're adding and subtracting fractions, you need a common denominator. -2 would be the same as -8 over 4. And -8 over 4 minus 15 over 4 would be -23 over 4. So we know that c is -23 over 4. This is our lovely gradient intercept form. We've subbed in the gradient, the y-intercept. Now you're asked for the general form. So we need to subtract y from both sides is maybe what I'm going to do. It's a bit less work. So just go 0 equals 3/4 x. I've just gone straight to putting the y in the center because you need x, y, the constant term. X minus y minus 23 over 4. But remember, a, b, and c need to be whole numbers. So what I suggest is multiply each term, multiply 0, that term, and that term by 4. Because if you multiply them by 4, the denominator is going to cancel out. Like 3/4 multiplied by 4 over 1 becomes 12 over 3, which is sorry, 12 over 4, sorry, which is 3. And same thing with this, 23 over 4 times 4 over 1 just cancels down to 23. So when you do that, multiply all of these terms by 4. 0 times 4 is 0. That times 4 is 3. That times 4 is negative 4. That times 4 is negative 23. So multiply by 4 as fractions are not allowed in general form. That's why. In gradient intercept form, fine. In general form, no. It has to be whole numbers. So that's a general form. If you want, you might want to just point out that you multiplied by 4, multiplied by 4, times by 4, times by 4, just for your own notes. Another one, find the equation of the line which passes through the point A, negative 1 and 5, and B, 2 and 3. So again, we're not given the gradient, so you're going to have to calculate it first. You're also not told which form to do it in this time, like gradient intercept or general form. So you can choose. I personally find the gradient intercept form the easiest, so I'm going to do that way. So y equals mx plus c. You're not given the gradient, so you're going to have to calculate x1, y1, x2, y2. You might want to label that. There's your gradient formula, rise over run. Plug in your y2 minus y1 over x2 minus x1. Really important to label everything, so let's do this. Yep, so x1, y1, just making you label this in case anyone's got the volume down, which you shouldn't have because you're missing out on information. X2, y2, so that you've subbed them in, and work out what the numerator is, work out what the denominator is. That's the numerator, what's the denominator? There you go. Simplified already. So that's our equation in so far in gradient intercept form. We've just subbed in the gradient. Now to find c, you can choose either the first point, x1, y1, to sub in, or you could choose the second point, x2, y2. Your choice. You can always check your answers by doing both. Now find c by subbing in a coordinate, is what we're doing. So I've chosen to sub in 2 and 3. Negative 2 over 3 times 2 over 1 is the same as negative 4 over 3. And then what do you need to do? You need to add 4 over 3 to both sides. So 4 over 3 to 3 is the same as 3 is the same as 9 over 3. 9 over 3 plus 4 over 3, what would that be? That would be 9 over 3 plus 4 over 3, 13 over 3. So our coordinate c is equal to 13 over 3. So let's just leave it in gradient intercept form because we weren't asked. Unless we're asked for general form, I would suggest just leave it in gradient intercept form because it's less work really, isn't it? For me anyway, if you use my method. Negative 2 over 3x plus 13 over 3. And the great thing is you can just leave them as fractions. You don't need to turn them into whole numbers. Another example. So interestingly enough, what if you're given it as a graph instead? It's just as easy, you just have to use the coordinates you're given. Find the equation of the line shown in the diagram below. So try to think, what two coordinates have we been shown? We have been shown, let's go through this. You can calculate the gradient first using the coordinates. So notice we've got one coordinate here, but we can remember, right, this is a coordinate because this is 0. Y-intercept, at the y-intercept x is 0, remember? And y in this case is 2. So x1, y1, x2, y2. So we can calculate the gradient. It doesn't say to write it in general or y-intercept form, so gradient intercept form, so I'm going to do gradient intercept form. Y equals mx plus c. Our m, we substitute in our values for x2 and y and so on. And you end up getting 3/4. So another thing is, we know what the y-intercept is, so that's easy. We can see it's 2. Y-intercept is 2. Pointing to that thing up here. So I should more so go like that. So y equals 3/4 x. That says 3/4 x. You can't see it. It's a 3/4 x plus 2. So another one, find the equation of the line shown in the diagram below. So we've got the y-intercept again, so we know that c is 9. So y equals mx plus 9 because we know the y-intercept. We need to calculate the gradient. So the y-intercept would have the coordinates 0, 9 because it's x equals 0. The x-intercept would have the coordinates 3, 0, and so on. Sub that into your gradient equation, and then you'll end up getting -3. So just y equals -3x plus 9 for this one. And that one's done. And another little one. Find the equation of the line shown in the diagram first. So let's see, we don't have the y-intercept, a bit awkward, no y-intercept. We've got the x-intercept, but that doesn't help us in terms of the y-intercept just yet. So find the gradient first, because you've got two coordinates. Y equals mx plus c. So this coordinate here is -4 and 0, x1, y1. This coordinate could be your x2, y2. Work out the gradient, y2 minus y1 over x2 minus x1. We get this, which simplifies to this. Therefore, y equals -2x plus c. And then find c by subbing in a coordinate. E.g., you could do -4 and 0. I'm going to do this one. You could also do this one, but I'm going to do this one. So y equals -2x plus c. Substitute in -4 and 0. That's a negative there. That times that is 8. And then 0 minus 8 is -8. So y equals -2x, subtract 8. So the hint for that was you can calculate the gradient first using the coordinates -4, 0 and 1, -10. You can then solve for c by choosing a point on the line and to solve in for x and y. So another example, find the equation of the line shown in the diagram below. So we have our y equals mx plus c. What do we have this time? We have two coordinates. They didn't give us the y-intercept, so we're going to have to do the old-fashioned way. Calculate the gradient using your x1, y1, x2, y2. Feel free to pause and just try it yourself first and then check with my answers. So we've got 2/3 as a gradient. Find c using either point. I used 1 and 5 because I just don't like dealing with negatives, so I subbed in 1 and 5. So we know a gradient, 1 and 5. 2/3 times 1 is just 2/3. And try to think 5 subtract 2/3 is just 4 1/3. So c is 4 1/3, you can write it like this. Or if you want to leave 4 times 3 plus 1 is 13 over 3 as an improper fraction. Lovely. Okay, and that is the end of the lesson.